Children, let us understand basic proportionality theorem. We will see its application. The statement is given as if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides those sides in the same proportion. Means in the triangle ABC, line L is parallel to line BC. It is already given to us, and it is being said that the remaining two sides means AB and AC, the line L is intersecting at two distinct points, that is D and E. Then the line divides means C, the line L is dividing line AB, the segment AB, in two parts, and even point E, because of line L we got this point E, and this point E is dividing segment AC into two parts, so that the line divides those sides in the same proportion. Given, children, L is parallel to BC, therefore we get, that is the basic proportionality theorem says, children, AD upon DB. You took one side of AB, you took AD upon DB is equal to AE upon EC. This is a basic proportionality theorem, the application. In the same manner, in the second figure also we can do in the same manner. See here, line L is parallel to line AC. It is already given to us that these two are parallel to each other. These two were parallel to each other. Therefore, by basic proportionality theorem, what it says, see, E and D are two distinct points. So BE upon EC, first finish with the same side, is equal to BD upon DE. Fine. In the same manner, see the third figure. Given line L is parallel to AB, these two are parallel to each other, AB, therefore CE, take one side, CE upon EB is equal to CD upon DE. Alright, children, these things you have to remember in your mind, how we are going to apply the basic proportionality theorem that we have seen. In the similar manner, the converse of the basic proportionality theorem, what it says, if a line divides any two sides of a triangle. So let us take a triangle, and in this triangle a line is dividing any two sides. The sides, let us be AB and AC. Line L is dividing AB and AC at 2 points in the same ratio. In the same ratio means it is already given to us that AD upon DB is equal to AE upon EC. If this is possible, then definitely line L will be parallel to segment or side BC. Alright, this is a converse of the basic proportionality theorem. So let us see the property of an angle bisector of a triangle, what it says. In a triangle, the angle bisector divides the side opposite to the angle in the ratio of the remaining sides. Now what it is, let us see. ABC is a triangle. In this triangle we have M as the angle bisector. AM as the angle bisector means AM is dividing angle A into two equal parts. Therefore, the theorem says that if AM is the angle bisector, then definitely by the angle bisector property, the opposite side BC is being divided into two parts because of AM. So the ratio BM upon MC will be equal to, children, belonging to BM the side is AB. So because BM you took in the numerator, so AB in the numerator upon CM belonging to CM is the side AC. So in the denominator AC. So this condition will take place if AM is the angle bisector which divides the opposite side in the ratio of BM upon MC is equal to AB upon AC. Similarly, in this triangle also, see, if BM is the angle bisector and it is an angle bisector of which angle? Angle bisector of angle B, dividing angle B into two equal parts. Therefore, on the opposite side we get two parts again. They may not be equal, but we get two parts, AM and MC. So their ratio AM upon MC will be equal to, belonging to AM is the side AB upon belonging to MC is the side BC. This happens because of the angle bisector property of a triangle. In the similar manner, if CM is the angle bisector of the angle C, it is dividing C into two equal parts. Therefore, the side opposite to angle C is the side AB. The side opposite to the angle C is divided into the ratio as, let us say, AM if we take in the numerator upon MB will be equal to, belonging to AM is AC. AC upon BC, because belonging to MB is BC. So this we have to remember in our mind as angle bisector of a triangle property. So let us see the practice set 1.2 of Geometry Maths 2. We have three figures here, children. We have to identify in this in which figure ray PM is the bisector of QPR, means angle P. See, angle P. When we say bisector, immediately we can use by the property of angle bisector theorem. What do we have? We can use it, children, in figure 1. Let us see the ratio. Because of the angle bisector, what happens to the ratio? PM is the ray PM. The ray PM, is it bisecting or no? That we have to see first, children. If it is bisecting, then we will have it as the angle bisector. For that, ray PM is given. Whether it is bisecting or no, we have to see. So first of all, let us take the ratios. PQ and PR. Belonging to PQ is QM and belonging to PR is MR. So let us find the ratio first. PQ upon PR, the ratio of the remaining two sides. That is 7 upon 3. then the ratio of the third side QM, because PQ is in the numerator, so belonging to that is QM in the numerator, upon PR in the denominator, so belonging to that RM in the denominator, is equal to QM is 3.5 and MR is 1.5. So what do we get? Solve this. The decimal, if we remove 35 upon 10 and 15 upon 10, take the reciprocal, 35 upon 10 multiplied by 10 upon 15. So we will get as 5 3s are 5 7s are is equal to 7 upon 3. Children, if you see here, the first one and the second one both are equal to each other. Therefore, we can say that PQ upon PR is equal to QM upon RM, and hence the ray PM is the angle bisector of angle QPR. So let us see in the same manner, what about figure 2? If we see figure 2, children, we have it as given to us. Again, let us draw once in this manner. It is given to us, and PR is given as ray. PR ray is given. It is not PR, children, it is PM R Q 7 6 and 8 and 10. Fine. Again in the same manner, this is a figure 2. Let us find first PR upon PQ. So PR upon PQ is equal to 7 upon 10. Belonging to PR is RM. So RM in the numerator. Belonging to PQ is QM. So QM in the denominator is equal to 6 upon 8 is equal to 2 3s are 6, 2 4s are 8, 3 upon 4. Therefore, PR upon PQ is not equal to RM upon QM. It is not equal to, children, because the values are not equal. Therefore, ray PM, because of the angle bisector theorem, is not an angle bisector of angle QPR. Let us see the figure 3, what it says. In the figure 3 also the same thing is given. If we see, let us draw once again the triangle. There is a ray given which is dividing the opposite side as QM and RM. This is 3.6, 4, 9 and 10. Again, let us find the ratio of the two remaining sides, PR upon PQ. PR upon PQ is equal to 10 upon 9. Now, PR upon PQ, so belonging to PR is RM. RM upon belonging to PQ is QM. QM is equal to 4 upon 3.6. That is equal to 4 multiplied by 1 upon 3.6. 4 multiplied by 1 upon 36 upon 10. What does that give us? 4 multiplied by 10 upon 36, the reciprocal if you take, and what do we get? 4 9s are 36, that is 10 upon 9. If you see, both the ratios are equal to each other, so we can write PR upon PQ is equal to RM upon QM. Hence, ray PM is an angle bisector of angle QPR. So this is the question number 1 of exercise 2.1. So let us see question number 2, children. In triangle PQR, find whether line NM is parallel to RQ. We have to find whether these two are parallel to each other. These two are parallel to each other means we have to think which property we have to use. If we use the property of basic proportionality theorem, in which it says if Pn upon Nr will be equal to Pm upon Mq, then definitely Nm will be parallel to Rq. So let us see the step 1. First of all, children, we need to find Pn. It is not given to us. So we know PR is equal to Pn plus Nr. The reason is PNR, the betweenness. Okay. So what else is given? The values of PR is given as 20 is equal to Pn is not given plus Nr is given as 8. So 20 minus 8 is equal to Pn. Therefore, Pn is equal to 12. This is one step, children. Let us see step 2. What the step 2 says. Similar manner, take the other side, children. We don't know MQ. So therefore, PQ is equal to PM plus MQ. And here also the betweenness PMQ. PQ, the value is 25, already given to us. PM is 15 plus MQ, that is 25 minus 15 is equal to MQ. Therefore, MQ is equal to 10. Now, children, we got PM and PN and MQ. Now let us find the ratios. So find step 3, what it says. The first ratio, Pn upon Nr is equal to 12 upon 8 is 4 3s are 12 and 4 2s are 8. We get 3 upon 2. The first equation. Now let us see the second one, that is Pm upon Mq. Pm upon Mq is equal to 15 upon MQ we found as 10, that is 5 3s are 5 2s are, that gives us 3 upon 2. So therefore from 1 and 2 what do we get? Pn upon Nr is equal to Pm upon Mq. So we can use the property of converse of basic proportionality theorem. What it says, if the ratios are equal to each other, then definitely the two lines will be parallel to each other. Alright, so hence